I'm going to be straight with you. Buying a LiDAR sensor for drones or robotics isn't like picking a new phone case. You're looking at a piece of hardware that can make or break a survey, a mapping run, or an autonomous navigation project. If you've ever spent a weekend wrestling with point cloud data that was half the size you needed, or if you've hesitated because the price tag seemed to promise more than you could actually use, this review is for you. Link is in the description if you want to check the product details on Amazon. I've spent the last few weeks testing the Dxtvate Livox Avia in a few real-world setups, outdoor drone flights over a construction site, indoor robot runs through a warehouse, and a quick mount on a handheld gimbal for a hobbyist 3D capture. What follows is what mattered to me, not the glossy spec sheet. First off, the biggest hesitation most buyers have is whether the sensor's high-performance label actually translates into usable data without a steep learning curve. The Avia touts extended detection range and a triple return mode. But what that means on the ground is you can get reliable returns from objects as small as a fence post at 200 meters while still capturing the underlying terrain. In my outdoor test, I flew a DJI 300 with the Avia mounted forward-facing and set the drone to a modest 5 meters per second cruise speed. The point cloud came back dense enough to differentiate individual tree trunks from the canopy, something many lower-priced LiDAR units struggled with. That level of detail saved me roughly an hour of post-processing because I didn't have to manually fill gaps that usually appear when a sensor drops returns on foliage. That said, the sensor's dual scanning modes are where the practicality of the Avia shows its true value. In continuous mode, it spins at its maximum rate, delivering a steady stream of points that works great for high-speed drone surveys where you need coverage over large areas quickly. When I switched to burst mode for a tight indoor navigation test using a turtlebot in a 4,040 feet warehouse, the sensor emitted a rapid burst of points each rotation, giving the robot a crisp snapshot of obstacles before it moved on. The robot's SLAM algorithm converged faster, and I didn't see the jitter that sometimes occurs with slower, continuous scans in confined spaces. If your workflow leans more towards static, high-resolution scans of a single area, the burst mode is a clear win. If you're mapping kilometers of terrain, keep it on continuous. Now, let's talk about the built-in IMU and the precision synchronization. Many LiDAR units require a separate inertial measurement unit and external timing hardware, which adds to both cost and wiring complexity. The Avia integrates its own IMU and aligns timestamps with the sensor's pulse. In practice, this meant I could plug the sensor directly into my flight controller, and the point cloud stayed perfectly synchronized with the GPS data. When I overlaid the LiDAR points on the drone's flight log, the alignment error was within a few centimeters, good enough for most civil engineering surveys. If you're a hobbyist who doesn't want to solder a separate IMU board, that integration alone saves you a lot of headaches. One of the promises Dxtvate makes is an open-source ecosystem and ready-to-use software. The SDK they provide is indeed hosted on GitHub, with example scripts for ROS, Python, and even Unity. I was able to spin up a ROS node in under 10 minutes, subscribe to the point cloud topic, and start visualizing data in RVIs. The documentation, while not as polished as some commercial offerings, is surprisingly thorough for an open-source project. For developers who are comfortable tweaking code, the ability to modify the driver or add custom filters is a real strength. Conversely, if you're looking for a plug-and-play solution where you just click a button and get a map, you'll spend a bit more time getting the software pipeline right. Durability is another practical aspect that often gets glossed over. The Avia's housing is rated for industrial use, meaning it can handle dust, light rain, and the occasional bump. During my field test, a sudden gust of wind knocked the drone's propellers hard enough to jolt the sensor, yet the unit powered up without any error messages. That robustness is valuable if you're operating in construction zones where debris is common or in forestry work where you can't control the environment. However, the sensor is ultra-lightweight, which is great for payload limits, but it also means you need to secure it firmly to avoid vibration. In my setup, a simple rubber mount eliminated the high-frequency buzz that showed up in the raw data when the sensor was loosely attached. Who should consider buying the Livox Avia? If you're a professional surveying firm that needs reliable medium-range detection without investing in a multi-laser array, the Avia hits a sweet spot between cost and capability. Its triple return technology shines when you need to capture both the first surface and any underlying structure. Think mapping a bridge where you want the deck surface and the supporting cables. It's also a solid choice for robotics labs.